Download this code from codegive.com, link in the description below. OK, let's delve into the frustrating world of Dxgi exception access violation errors. This error is a common pain point for developers working with Direct3D, especially when dealing with resources, threading, or incorrect usage of the Dxgi, directx graphics infrastructure, API. Understanding the Dxgi exception access violation error. The Dxgi exception access violation error, typically represented by error code 0xC0000005, signals that your application is attempting to read from or write to memory that it doesn't have permission to access. This can happen in various scenarios related to Direct3D and Dxgi. Resource access conflicts. Multiple threads trying to access the same Direct3D resource, example a texture or a buffer, concurrently without proper synchronization. This is a very common cause. Incorrect resource lifetime management. Attempting to use a Direct3D resource after it has been released, freed from memory. This is a classic use after free error. Data corruption. Memory corruption caused by bugs elsewhere in your code can sometimes manifest as a Dxgi error because the corrupted data is used within the Direct3D pipeline. Driver issues. Although less common, a bug in the graphics driver itself could potentially lead to this error. This is rare, but it's worth considering if you've ruled out other possibilities. Incorrect Dxgi usage. Calling Dxgi functions with invalid parameters, like passing null per where a valid pointer is expected, or using an incorrect resource format. Improper synchronization in multi-GPU scenarios. When dealing with multiple GPUs, ensure proper synchronization of resource usage between the different devices. Shader issues. A shader that attempts to access invalid memory locations or has other memory corruption issues can also trigger an access violation. Incorrect swap chain usage. Problems with swap chain creation, resizing, or presentation can sometimes result in access violations. How to diagnose and fix Dxgi exception access violation errors. 1. Enable the Direct3D debug layer. The Direct3D debug layer is your first and best friend. It provides valuable error messages, warnings, and debug information that can pinpoint the source of the problem. Programmatic enablement. Recommended. Modify your Direct3D initialization code to enable the debug layer. This is the most robust way to ensure it's always active during debugging. Explanation. We define create device flags and set the D3D11_create_device_debug flag if we're in a debug build, _debug is defined. We call D3D11 create device, or D3D12 create device. After creating the device, we query for the ID3D11 debug interface, or ID3D12 debug. If we get the ID3D11 debug interface, we then query for ID3D11 info queue and set break on severity to true for D3D11_message_severity_corruption and D3D11_message_severity_error. This will cause the debugger to break immediately when these types of errors are detected, giving you the precise line of code causing the problem. Using the graphics diagnostics tool, Visual Studio. In Visual Studio, go to debug-graphics-start graphics debugging. This will launch your application with the graphics diagnostics tool attached. Reproduce the error. The graphics diagnostics tool will capture a frame and allow you to inspect Direct3D API calls, resource states, and shader execution. Examine the event list in the graphics diagnostics window. Look for red error icons or warnings near the time the crash occurred. These will provide clues about the problem. Use the object table to inspect the state of direct 3D resources, textures, buffers, etc., at the time of the crash. Check if resources are in a valid state. The pipeline state view shows the current pipeline configuration. Ensure that vertex buffers, index buffers, shaders, and other pipeline elements are correctly bound. To read the debug output carefully. When the debug layer is enabled, Direct3D will print error and warning messages to the debug output, usually visible in the Visual Studio output window. These messages are critical for diagnosing the problem. Pay close attention to error codes. Look for specific Direct3D error codes. Example Dxgi _error invalid call, invalid arg. Search the Microsoft documentation for these error codes to understand their meaning. Object names / addresses. The debug output will often mention the names or memory addresses of the Direct3D resources involved in the error. This helps you narrow down the problem. API call sequence. The debug output might show the sequence of Direct3D API calls leading up to the error. This can help you identify which call is triggering the access violation. 3-thread synchronization, critical. If you're using multiple threads to interact with Direct3D, ensure that you have proper synchronization mechanisms in place to prevent race conditions. Direct3D resources are generally not thread-safe unless explicitly designed to be. Critical sections / mutexes. Use critical sections, example critical _section in Windows, or mutexes to protect access to Direct3D resources from multiple threads. Ensure that only one thread can access a resource at a time. Read / write locks. If you have scenarios where multiple threads need to read a resource concurrently but only one thread can write to it, consider using read / write locks, example srlock in Windows. Atomic operations. For simple operations, example incrementing a counter, use atomic operations to avoid race conditions. Double buffering / triple buffering. Consider using double buffering or triple buffering to avoid the need for synchronization in some cases. For example, one thread can render to a back buffer while another thread presents the front buffer. Here's an example of using a critical section to protect access to a Direct3D texture. Important. Always release the critical section, or mutex, in a finally block, or equivalent in your language, to ensure that the lock is released even if an exception occurs. Otherwise, you'll create a deadlock. For resource lifetime management. Ensure that you are not using Direct3D resources after they have been released. This is a very common source of errors. Reference counting. Direct3D uses reference counting to manage the lifetime of COM objects, like textures, buffers, and shaders. When you're finished with a resource, call its release method to decrement the reference count. When the reference count reaches 0, the resource is automatically freed. Debugging tips. Set breakpoints in the release methods of your Direct3D resource wrappers or classes. Verify that release is being called at the expected times. Use the graphics diagnostics tool to track the lifetime of Direct3D resources. The tool shows when resources are created and destroyed. Consider using smart pointers, example Microsoft WRL-COM-PTR or STD unique_PTR, to automatically manage the lifetime of Direct3D resources. If you have complex resource dependencies, make sure to release resources in the correct order. Example using Microsoft WRL-COM-PTR. 5. Check resource creation and usage asterisk. Asterisk valid parameters asterisk double check that you're passing valid parameters to Direct3D API calls when creating and using resources. Pay particular attention to asterisk resource formats, example Dxgi underscore format underscore R8G8B8A8 underscore unorm. Ensure that the format is supported by the device and that it matches the data you're providing. Asterisk resource dimensions, width, height, depth. Make sure that the dimensions are within the limits of the device and that they are appropriate for the intended usage. Asterisk resource usage flags, example D3D11 underscore usage underscore default, D3D11 underscore usage underscore dynamic, D3D11 underscore usage underscore staging. Choose the correct usage flag based on how you plan to access and modify the resource. Asterisk bind flags, example D3D11 underscore bind underscore shader underscore resource, D3D11 underscore bind underscore render underscore target, D3D11 underscore bind underscore depth underscore stencil. Specify the correct bind flags to indicate how the resource will be used in the rendering pipeline. Asterisk resource alignment asterisk some resources, example constant buffers, require specific alignment in memory. Ensure that your data is properly aligned. Use the __DXspec, align, 16, attribute in C++ to ensure proper alignment. Asterisk resource limits asterisk Direct3D devices have limits on the maximum size of resources. Check the device capabilities to ensure that your resources don't exceed these limits. Use ID3D11 device check feature support to query for device capabilities. Asterisk resource states asterisk ensure that the resources are in a valid state for the operation you are trying to perform. For example, if you are trying to write to a texture, make sure it isn't currently bound as a render target. If you are using Direct3D12, you must explicitly manage resource barriers to control resource states. 6. Shader debugging asterisk. If you suspect that the error might be in your shaders, use the shader debugger in Visual Studio or other shader debugging tools to step through the shader code and inspect the values of variables. Asterisk check for out-of-bounds access asterisk make sure that your shaders aren't trying to access memory outside the bounds of textures, buffers, or arrays. Asterisk nans and infinities asterisk look for nan, not a number, or infinity values in shader variables, as these can indicate numerical instability or errors in your calculations. Asterisk divide by zero asterisk check for divide by zero errors, which can lead to undefined behavior. Asterisk resource binding errors asterisk ensure that you've correctly bound textures, buffers, and samplers to the shader. 7. Swap chain issues asterisk. Problems with swap chain creation, resizing, or presentation can sometimes cause access violations. Asterisk valid swap chain description asterisk make sure that the Dxgi underscore swap underscore chain underscore desk structure is properly initialized with valid values for the buffer count, format, refresh rate, etc. Asterisk window handle asterisk ensure that the window handle passed to Dxgi factory create swap chain is valid. Asterisk full screen mode asterisk if you're using full screen mode, make sure that the display mode is supported by the adapter. Asterisk resize buffers asterisk when the window is resized, call Dxgi swap chain resize buffers to resize the swap chain buffers. Handle the Dxgi underscore error underscore device underscore removed or Dxgi underscore error underscore device underscore reset errors that can occur during resize. Asterisk presentation interval asterisk the presentation interval, specified in Dxgi swap chain present, can affect performance and synchronization. Experiment with different presentation intervals to see if it resolves the issue. 8. Driver updates asterisk. Although less common, a bug in the graphics driver could potentially lead to access violations. Try updating to the latest graphics driver from the GPU vendor's website, NVIDIA, AMD, or Intel. 9 Minimal reproducible example asterisk. If you're struggling to find the cause of the error, try to create a minimal, self-contained example that reproduces the problem. This will make it easier to isolate the issue and share it with others for help. 10 Debugging tools. Visual Studio Graphics Debugger a powerful tool for capturing and analyzing frames, inspecting resource states, and debugging shaders. Pix, Performance Investigator for Xbox and Windows, a more advanced performance analysis tool for direct 3D applications. It can help you identify bottlenecks and other performance issues. Pix is more focused on performance than debugging access violations, but it can still be helpful. WinDBG a powerful but complex debugger that can be used to analyze crashes and memory corruption issues. GPU View a performance analysis tool for graphics drivers. It can help you identify driver-related issues. Example, common scenario, incorrect resource usage. Let's say you're creating a texture and using it as a render target. You might encounter an access violation if you try to bind the texture as a shader resource while it's still bound as a render target. Fix unbind the render target view before creating the shader resource view or using the texture as a shader resource. You can do this by setting the render target to null before creating the shader resource view and binding it to the shader. You can also release the render target view and create a new one. In the code sample I unbound the render target view. In summary Dxgi exception access violation errors are challenging, but by systematically using the direct 3D debug layer, paying close attention to thread synchronization, managing resource lifetimes carefully, and using debugging tools, you can track down the source of the problem and resolve it. Remember to create minimal reproducible examples to help you isolate the issue. Good luck.